Have you ever wondered how data is stored and manipulated in Python? In the realm of programming, understanding data structures is pivotal. These are not just abstract concepts, but practical tools that help us solve real-world problems. One of the most common data structures in Python is the list. It's an ordered collection of items indexed and even allows duplicates. Picture a shopping list with items like apple, banana, cherry, and even numbers like 1, 2, 3, 4, and 5. Then there's the tuple, a close relative of the list. However, unlike a list, a tuple is immutable. It can't be changed after it's created. Imagine a point in a two-dimensional space, represented as a tuple with two elements, like 3 and 4, or dimensions of a box as 10, 20, and 30. Next up, we have dictionaries. Think of them as personal profiles storing key value pairs. For example, a dictionary could store a person's name as John, age is 30, and city as New York. The key here is that each key is unique, just like each piece of information about a person. Sets, on the other hand, are unordered collections of unique elements. If you have a set of unique numbers or vowels, you have exactly that. No duplicates, no order. Strings are a different kind of beast. They're a sequence of characters. Any text like "Hello World" is a string. Arrays, which require the array module, are homogeneous collections of elements, usually of the same data type. An array of integers could contain numbers like 1, 2, 3, 4, and 5. Queues implement a first in first out data structure. It's like a line at a grocery store. The first one to get in line is the first one to check out. Stacks implement a last in first out data structure. Think of a stack of plates. The last plate you put on top is the first one you'll pick up. Dequets, or double-ended queues, allow fast insertions and removals from both ends. They're like a deck of cards where you can draw from the top or the bottom. Linked lists are a bit more complex. Each element or node holds a value and a reference to the next node, forming a chain of connected nodes. Trees are hierarchical data structures with nodes organized in a tree-like structure, while graphs can represent complex relationships between nodes and edges. In conclusion, these data structures provide different ways to store and manipulate data in Python, each suited to specific use cases and problem-solving scenarios. So the next time you're faced with a problem, remember, the right data structure might just be the key to the solution.